Hi everyone. This is an example of a solution stoichiometry problem that incorporates mass. Just because we're doing solution stoichiometry doesn't mean that we're not going to see mass anymore. We have all of these different possibilities and we can navigate our way through these 4 steps in, at this point, one of 12 different ways. Here's our example. What volume of 0.200 mole per liter copper 2 nitrate solution is required to completely react with 0.550 grams of solid aluminum? Our first step is to balance the equation and interpret the question. As always, we're on the lookout for a key phrase or two to help us understand what the reaction is going to be. One strategy is to read the question with the chemical before the key phrase, and the chemical after. Let's see what that sounds like. Copper 2 nitrate react with aluminum. That's going to help. An alternative strategy is to read the question and skip the numbers. What volume of copper 2 nitrate solution is required to completely react with solid aluminum? We need to do what we need to do to come up with the balanced equation. Here we go. The Roman numeral 2 on the copper means the charge is 2 plus. Nitrate is a 1 minus. Reacting with aluminum, no subscript for a metal. The copper and the aluminum switch places. The aluminum is a 3 plus, and the nitrate a 1 minus. Now we balance this equation. So we end up with 3 coppers on either side, 6 nitrates, and 2 aluminums on opposite sides of the equation. Let's get to our interpretation. What volume of concentration chemical? There's our standard way that this information is presented to us to logically link those 3 things together. Volume of concentration chemical. So we're looking for the volume of copper 2 nitrate. We have the concentration, 0.200 moles per liter. And that's where the question mark is, R. What else do we have? 0.550 grams of solid aluminum. That's the mass of the aluminum. So here under the aluminum, I'm going to put M for mass, and it's 0.550 grams. Here's the R, this other set of numbers, the G. All that, step 1. Take your time to figure out what the reaction is, balance it, interpret the question, be really clear what's being given to you and what you're required to find out. Then we move on to step 2. Find moles. We have these 3 possibilities, and they're all still going to show up sometimes. We can find moles by reading, sometimes concentration times volume, but in this question, mass over molar mass. We have the mass, 0.550 grams, and that's grams of aluminum. So we need to use the molar mass of aluminum, which the periodic table tells me is 26.98 grams per mole. We're going to find moles and move on to step 3, multiply by R over G. We have these nice labels, R and G. R is 3, G 2, times 3 over 2. All of that work, our initial work and the ratio, is what we've been calling red M. If we were to stop right now after the R over G, we would have this red M. That's the moles of the required. But now we're going to solve pretty explicitly what volume. We're looking for the volume, so we pick our formula here. Volume is the red N, which we have right now, divide by concentration. So here, really important, we're going to divide by the concentration, 0.200 moles per liter. Now that we have the calculation set up, we can get to pushing buttons. 0.550 divided by 26.98 times 3 over 2 divided by 0.200. That equals 0.15289,103. Which, when we check our significant digits in the question, both of the values given to us by the question have 3 significant digits. So we round this off appropriately. 0.153. And this was the volume that we found when we do the algebra here of the units, or we could just remember that the volume in liters. Something we haven't mentioned before, it's worth it to take just a moment to think about, does that make sense? Would about half a gram of aluminum react with 153 milliliters? Yeah, I don't exactly know, but that feels right. It's not some crazy out of the ballpark number. This fits. When we have a stoichiometry problem, no matter what kind of stoichiometry problem it happens to be, we're always going to follow these 4 steps. We're going to work on the equation first, wrap our head around exactly what's going on, find moles, multiply by R over G, and solve. Big heads up. Here we're dividing. Sometimes we might end up multiplying as our last step. These 2 scenarios with solution stoichiometry, we are dividing. Don't forget to watch those significant digits and those units, and I hope that helps.